Welcome everyone. Thank you for joining today's workshop session with MajorDom on Moonchain and ERC-4337. In today's workshop, we will dive deep into ERC-4337 and account abstraction, exploring how these innovations are transforming blockchain interactions and enhancing user experience. Our focus will be on understanding the significance of account abstraction, its objectives, and practical applications within the Moonchain ecosystem. We cover topics like user-friendly wallets, flexible transaction models, and enhanced security that ERC-4337 brings to decentralized applications. So let's get started and discover how Moonchain is pioneering advancements in blockchain space. So welcome to the introduction of ERC-4337 and the importance of account abstraction. This slide gives us an overview of the basics of ERC-4337 and highlights why account abstraction is so crucial for the future of Ethereum. Account abstraction is an Ethereum improvement proposal that supports the separation of accounts and the authentication function. So before it wasn't possible to do this, so we are opening new possibilities to designing wallets and transactions. This separation is crucial because until now, only externally owned accounts or user-controlled accounts could initiate transactions. With account abstraction, smart contracts can now act as independent accounts, which significantly enhances the flexibility and security for user interactions on the blockchain. Yeah, why is this important? Like I said, we enhance the security for our users. With account abstractions, security features like multi-signature rules can be customized. This gives users more control and makes wallets more resilient against attacks. We also could provide fee-free transactions through sponsorship models enabled by paymasters, which are an optional feature of ERC-4337. And with this feature, transaction fees can be covered on the behalf of the user, which opens new use cases and makes blockchain applications way more accessible. Also, we can process automation. Account abstraction enables the automation of recurring or conditional transactions, which is specifically beneficial for dApps and user-friendly wallet solutions. These new possibilities makes Ethereum a more attractive and accessible platform for both users and developers. ERC-4337 and account abstraction ensure a more secure and flexible blockchain, easing onboarding and fostering innovations for existing users alike. So in this slide, we were focusing on the fundamental differences between traditional transactions and the new introduced user operations, which are brought by account abstraction. So regular transactions on Ethereum are typically initiated by externally owned accounts, a wallet pair, a key pair, which are user-controlled accounts capable of sending transactions, including call data to interact with smart contracts. However, EOAs themselves lack programmable functionality and can only trigger actions externally, rather than executing complex logic within the account. This limitation restricts flexibility, as all account-specific logic has to reside within separate smart contracts rather than within the account itself. User operations, as introduced with ERC-4337, transform the way transactions work on Ethereum by allowing smart contracts to act as an account, referred to contract accounts. Traditionally, externally owned accounts could initiate transactions, limiting only externally owned accounts could initiate transactions, which limits the flexibility because EIAs don't support programmable logic. With user operations, contract accounts gain the capability to initiate transactions directly, enabling a new class of functionality that previously unattainably within the account itself. By giving smart contracts the power to function as an account abstraction brings Ethereum closer to a fully programmable financial ecosystem. It enables user-friendly and feature-rich applications, as users can now interact with the blockchain in ways that feel more intuitive and secure. Instead of relying solely on EOAs with limited function, developers can create applications that leverage smart contract accounts to handle intricate workflows and access controls natively. This paradigm shift sets the foundation for a more versatile Ethereum, capable of supporting sophisticated user-focused blockchain applications that were previously challenging to implement under the traditional account model. So this set to the differences between regular transactions and user operations. I now want to introduce you with the 5 most important roles of ERC-4337, which are the user, the bundler, the entry point, the paymaster, which is an optional entity, as well as the smart contract account. So our user is the originator of the transaction process. They initiate the actions by creating user operations, which are requests that specify what they want to execute on the blockchain, such as transferring funds or interacting with a decentralized application. This user-centric approach allows individuals to initiate transactions without directly involving externally owned accounts, which are limited to basic send and receive actions. Instead, the user can leverage smart contract-based accounts that introduce programmable logic, which adds a layer of flexibility and personalization to the transaction initiation process, making it easier for users to interact with the blockchain applications in ways that align with their preferences and security needs. Our next entity is the bundler, which serves as an aggregator, collecting multiple user operations from different users and bundling them into a single batch for submitting to the blockchain. By combining multiple operations into one transaction, the bundler optimizes transaction efficiency, reducing network load and potentially lowering gas costs for users. This batching process not only saves on transaction fees, but also contributes to a smoother user experience by minimizing delays associated with individual transactions. The bundler acts as a bridge, consolidating multiple actions and sending them to the blockchain in an efficient and scalable way. And it sends it to our entry point, which is our first smart contract in our pipeline. The entry point is a crucial component that functions as a central smart contract for managing and verifying each user operation. It acts as a gatekeeper and checks the validity and authorization of each operation, ensuring that only legitimate actions proceed. These components play a key role in maintaining the integrity and security of the transaction process. The entry point manages 2 loops: the validation loop, which confirms the legitimacy of the operations, and the execution loop, which handles then the execution of the validated operations. By enforcing these checks, the entry point guarantees that every action complies with the predefined security standards, thus safeguarding the network from unauthorized or potentially malicious activities. We then have our optionally paymaster. The paymaster, like I said, is an optional yet powerful role within the ERC-4337 framework. It allows third parties to sponsor transaction fees on behalf of our user, which can be particularly useful for applications aiming to provide a seamlessly fee-free experience. For instance, a debt could cover transaction fees for a new user to encourage adoption, or a company might subsidize fees as a part of a promotional campaign. This sponsorship model helps remove a significant barrier to entry, making blockchain more accessible to users who may be hesitant about paying fees. The Paymaster is an innovative feature that allows for new business models and enhanced user experience by enabling fee-free interactions. Smart contract accounts are the last part and the most important part and our heart of account abstraction. They represent the user's account by enhanced capabilities and which are enabled by smart contracts. Unlike traditional EOAs, externally owned accounts, which are limited to the simple transactions, the smart contract account can execute complex operations directly, such as multi-signature verification, custom security measurements, and programmable transaction conditions. For example, users can implement multi-signature requirements where multiple approvals are needed for high-value transactions, or add social recovery options, allowing the trusted contacts to help recover account access if needed. This advanced account structure is the heart of the flexibility and security improvements introduced by ERC-4337, providing users with a highly customizable and robust framework for managing their digital assets and interact on the blockchain. Each of these roles collaborates to facilitate account abstraction, creating a more accessible, secure, and versatile transaction model on the blockchain. Together, they enable a shift from traditional rigid account structure to a more dynamic and user-focused approach. We're now going to talk about this diagram, in which we are looking at how ERC-3473's account abstraction operates and the core components involved. So let's break down these roles and processes. We are starting with the user operation, which you can see here, which represents a transaction or an action initiated by a user. These operations are placed in the alt mempool, which you can see here, which is a specialized memory pool that temporarily holds user operations before they are processed. The bundler then steps in. Its job is to gather multiple user operations from the alt mempool, organizing them in a single batch for submission to the blockchain. This batching process helps save on gas costs, as it's more efficient to submit several user operations together than separately. Before submitting, the bundler ensures each operation's validity by working with the entry point contract, which is the first smart contract, which you can see here. A central smart contract that handles the validation and processing of these operations. Sorry. The entry point is a central smart contract and serves as the backbone of ERC-3473 system. It plays a dual role of security and coordination, ensuring that only authorized and valid user operations are processed. This is where the valid loop and the execution loop comes into play. The first loop, the validation loop, which you can see here, is responsible for confirming the authenticity and correctness of each user operation. It checks elements like user permission, required funds, and any other conditions that need to be met before an operation can be processed. This step is essential for security, as it filters out invalid or potentially malicious operations, allowing only verified transactions to advance to the next stage. The next loop, or the next step, is the execution loop, which you can see here. Sorry. Once a user operation passes the validation, it moves into the execution loop. Here, the entry point contract interacts with the account, often our smart contract account, which you can see here, to carry out the desired transaction. This includes transferring assets, interacting with the debt, or fulfilling a predefined condition within the smart contract. The execution loop ensures that the actual operations are completed according to the user's intentions, with the account acting as the primary agent for performing the transaction. Additionally, there's the aggregator. While optional, the aggregator plays a valuable role in enhancing transaction efficiency. It combines multiple signatures into a single aggregated signature when user operations involve multiple accounts. This optimization is especially beneficial for reducing on-chain data and costs, as fewer signatures need to be stored and processed. No, here, this is the aggregator, not this one. This one is the paymaster, which is also an optional component that can cover transaction fees, allowing for fee-free transaction for the user. This feature is particularly appealing for user experience, as it opens the door for sponsored transaction, making blockchain interactions smoother and potentially more accessible. Together, these components streamline the process, enhance the user experience, and provide flexible transaction handling options within the ERC-4337 framework. So now to the objectives and vision of ERC-4337. We are seeing a transformative shift in how user interact with the blockchain, specifically through the concept of account abstraction. Traditionally, on Ethereum, only externally owned accounts controlled by private keys could initiate transactions. This limited flexibility for users and centralized control over certain transaction aspects. ERC-4473 changes that by allowing smart contracts to function as accounts themselves. This means users can configure these smart contract accounts with specific rules, permissions, and conditions, providing a much more customizable experience. By enabling smart contracts as account, ERC-4473 lets users design their own account security and transaction processes. For example, users can set up multi-signature authentication, meaning that multiple keys might be required to approve a transaction, enhancing security. They could also integrate social recovery options when trusted individuals can help recover access if a user loses their private key. Moreover, account abstraction supports sponsor-based transactions through the paymasters, meaning transaction fees could be covered by a third party, allowing for gasless transactions. This is particularly valuable for users who may not hold ETH but still want to interact with Ethereum dApps. Through paymasters, companies or sponsors can pay the transaction fees on behalf of the users, potentially increasing adoption by reducing cost barriers. Additionally, it would be possible to allow the payment of gas costs, for example, in a stable coin, for example, or some other coin which is not specifically Ethereum. The long-term version of ERC-4373 is not just limited to more flexibility and control. It also aims to create a safer, more accessible blockchain environment by empowering users to control how transactions are authorized, automated, and executed. This flexibility enhances security This flexibility and enhanced security are steps towards a user-centric, scalable blockchain ecosystem that can meet the demands of a broader audience in Web3. Yeah, the advantages for the user experience are pretty on the table. So you can provide features like social recovery, which traditionally are not possible. If someone loses access to their private keys, their funds or asset can be irretrievably lost. And ERC-3473 offers a solution by allowing trusted individuals to help restore access to the account, making blockchain wallets more user-friendly and resilient. You can think about another point, which is multi-signature and security it provides. You would be able to allow a customized logic on which you allow that as soon as 3 of 5 keys are provided, the funds can be moved. Or, for example, taking some time for allow the movement of 100% of your funds. For example, it's just on your open, fully relying on your fantasy. So everything you can code, you can do with account abstraction. Yeah, and lastly, the last advantage is the flexible payment methods, which already told allow for fee-free transaction processing. In this case, the paymaster would pay for the transaction costs, or it would also be possible to provide a logic in which the user could pay his gas fees in another token than Ethereum. So in this case, the logic would provide in the background that the gas would be paid in Ethereum anyways, but allow that the user don't have to pay it in Ethereum on its own. Then we also wanted to go over to the use cases, which I already kind of talked about, which are user-friendly wallets and business solutions. So Account Abstraction enables simplified wallets that don't require users to understand blockchain details, making crypto more accessible for broader audience. For businesses, this can also mean that they can integrate blockchain in ways that streamline workflows. For example, e-commerce platforms using blockchain-based payments without exposing customers to the complexities of crypto transactions or gas fees. The next point could be incentives and sponsorship models, which are a feature which is made by the Paymaster feature, which allows dApps to cover transaction fees. This could be revolutionary for customer engagement in apps and games. For instance, a game might cover transaction fees for players when they earn rewards, making the experience feel seamlessly. Similarly, loyalty programs can reward users for fee-free transactions, adding value without additional cost barriers. Finally, self-managed identities and specialized applications demonstrate how ERC-4337 can be used to securely manage digital identities and assets. In gaming, players can truly own and control in-game items and property without relying on central authority. For NFTs and digital art, artists can enforce royalties and manage asset transfers independently. This has brought applications beyond gaming, reaching into fields like healthcare, IoT, supply chain, where secure and autonomous asset management is essential. Overall, these use cases showcase how ERC-4473 is not just an upgrade, but a pathway to integrating blockchain more seamlessly into our everyday lives, creating new possibilities across multiple sectors. So with this said, I would like to thank all of you for your attention and participation in today's workshop on ERC-4473 and account abstraction. I hope the session provided you with valuable insights into how ERC-4473 is reshaping blockchain interactions, enhancing user experience, and opening a new possibility in Web3. If you're interested in learning more, please feel free to explore additional resources, which are down in the description under the video. You also could find more information on our homepage, moonchain.com. A special thanks to the sources that supported this presentation, which include the Alchemy Account Abstraction playlist and the StackUp blog, which was an inspiration for the diagram I've used. I would like to encourage you to check out these to deepen your understanding of this exciting technology. Once again, thank you, and we look forward to see how you're leveraging these tools and concepts in your projects. Feel free to reach out with any questions or join our community on Telegram or Discord for continued learning and collaboration. Thanks for joining, and happy coding.